everybody, this is Mrs. Anderson, and we're back doing Master Math Mentor, Section 5, and we are specifically in the examples that are labeled 6 right now. And so the key right here is that we are about to determine what happens as x is approaching the positive and negative infinity. And a lot of times when we're doing this work during tests and quizzes and homeworks, we kind of forget what that positive infinity means. This is talking about the horizontal asymptotes, okay? So as we're reaching out farther and farther and farther, what's happening, okay? So we first examine the graphs of 1 over x, which is the solid curve, and 1 over x squared, which is the dash curve. Okay, we see that both of these are asymptotic to the x-axis. So that means that this guy, as I keep going out and out and out, either direction is approaching 0. And consequently, same thing when I have this power on the bottom, okay, x squared, I am still approaching 0. So that we can say anytime we have a over x to some power, then we're going to get 0 for any positive value of n greater than 1, where a is a constant. Okay, so these are really important rules right here, meaning we have to have a power higher than 1, and the value on top has to be a constant. So right now, we first plug in infinity. So if I plug in a number, and I'm going to be getting this to be bigger and bigger and bigger and bigger and bigger, and this is going to be bigger and bigger and bigger positive, so this is going to be an indeterminate. We don't know what's going to happen from it. So we divide each term by x, okay, because we want to see what happens when we get rid of those x's. So I'm going to write this here, the limit as x approaches infinity for x, and now I'm going to divide by that x. And remember, whatever I do to the top, I have to do to the bottom. Okay, so let's think about this. These x's cross out, so I have 4 minus 3 over x, and I have 8 plus 1 over x. Well, we've just learned that anytime the top is a constant and this power is greater than 1, well, in this case it's not, but we can refer back to this rule right here, these become zeros. So we're going to have 4 over 8, or 1 over 2, is our limit. Now, again, this is all perfectly good writing. This is what I would expect on your paper, okay, every single time. So now, we again have this infinity situation, so we notice that we're going to keep getting positive, we're going to keep getting positive, so what's really happening? We don't know. So we want to divide by the biggest term, okay? Not the smallest, but the biggest. So in that case, that's going to be that squared here. So we're going to take the limit as x approaches negative infinity. I'm going to do 6x minus x, or over x squared, minus 7 over x squared. X squared over x squared, minus 3 over x squared. Okay, now let's kind of look at this, and maybe we have to do a couple extra lines of work just to make sure. This becomes a 1. We know that this is going to become a 0. We know this from above becomes a 0. And then this is going to become 6 over x, which we know becomes 0. Now these arrows crossing out and showing what the new value is are perfectly acceptable, so don't hesitate to do that. And so 0 over 1 is a value. That's going to be 0, and that is your limit. Okay, last one. Okay, so pause the video a second, try it, and see what happens. Okay, see if you're going to end up agreeing with me. All right? All right, so coming back in here, this is our highest power. So I write by limit as x approaches infinity of 2x fourth over x to the fourth, and then 5x cubed over x to the fourth plus 1 over x to the fourth. Now, this is pretty nice because this guy is going to disappear. So that becomes 2. And I'm actually going to write this down here. This becomes 5 over x, and then this becomes 0. All right? So again, we know that 5 over x becomes 0, so we have 2 over 0, like that. So once we get there and we keep doing the rest of our work, we're going to end up finding that that's going to be infinity. Okay, so we're going to be kind of leaning towards an infinity going up. So let's talk about what that looks like. So let me graph this really quick for us, just so you can see. And sometimes I'm not always too good in this thing. Let's escape, not what I wanted. Okay, I guess I'll just do tab up. Okay, so I'm going to clear this guy out, and I'm going to do 2x to the fourth. And then I'm going to come down, and I'm going to divide it by parentheses. 5x cubed, come down, and do plus 1. And sometimes when I need to understand better what's going on, using your calculator is a great tool, okay? So that's perfectly fine, and I'm going to just do Control T. That's how I get rid of my table. And we can see that as I'm coming out towards positive infinity, my values keep getting higher, okay? So I would write, when you have this happen, your answer is x as approaches infinity of 2x to the fourth over 5x cubed plus 1 is going to not exist, okay? Because we have that value on that 0 on the bottom. If you did more research, you could come up because it's going towards positive infinity as your reason. But remember, does not exist is perfectly acceptable as well. All right, best of luck.